Start. Hello everyone. Good morning. Durga, Swati, Raja, Rutvika, Sajid, Joshna, Chintu. Good morning everyone. How are you all? So we have to see a periodic table and we can imagine last class today for periodic table. ठीक है? Jameer, Rutvika, fine, good. How are you all? Doing good? ठीक है? So for this test, I think we will have electronegativity. In last class, we have completed electronegativity. ठीक है ना? So today we have to do the miscellaneous things only. ठीक है? Like the diagonal relationship is there, anomalous behavior is there. We will see the nature of oxides, valency, oxidation state. Correct. So that much is sufficient. ठीक है ना? And I told you Haney Smith and all these things are not written in NCERT. When you will go in NCERT, they have focused mainly on 1-2 points only. The first point which they have written is electronegativity is a qualitative approach. There are two terms now. One is qualitative and the other one is quantitative. So have you read that from NCERT? They have written there key it is a qualitative approach. Exact magnitude finding is not possible. So they are giving relative values. Like randomly they have given fluorine as 4. So these points are there. So hope you have read this. Okay? Qualitative. This point they can frame a question based on this. Achha, there are many uses of electronegativity. See, a few uses we have written. One more question we can do and we can move to the next topic. One question was like this: ki if delta En is more than 1.7, if delta En is more than 1.7 for a compound, then it is soluble in. It is soluble in. Now see, these are application based. We have to use our brains also a bit. Okay? So one thing we know, and the options are like this. Okay, first one is your benzene. The second one is given CCl4. Third one is given CH2. Fourth one is water. So what do you think in which compound it will be soluble? In which compound it will be soluble? So we can simply say if En difference is more than 1.7 according to Pauling scale, that means this one is an ionic compound. This one is an ionic compound. So we know ki like dissolve like, polar compounds will dissolve in polar solvent. So a bit of brain you will apply and you will get the answer ki my answer is H2O. ठीक है ना? So you will have to practice many questions. ठीक है ना? We can deliver the theoretical part, we can tell you the concepts, but many different questions can be framed up based on that. Sorry. So you have to solve all those type of questions. ठीक है? So hope you have understood. We will move to the next part now, and whatever we are having today, that is just like miscellaneous thing only. ठीक है ना? In NCERT there is nothing about a Pauling formula 1.7, 2.1, Haney Smith, all these are not there. ठीक है? Okay. In fact, they have written more about metallic character, non-metallic character. They have said about the reactivity. ठीक है? So now let's talk about few things. Let's start with the first point, that is your valency. ठीक है? So valency is the first point which we are going to study today. Okay? Then there is oxidation state term. We will not go in detail all these things because all these are like oxidation state we will study mainly in redox chapter. Okay? Correct. So hope you have revised everything. You will have your test also. Clear? So let's see these points. So first of all, they are telling about valency. They are saying कि for representative element mainly, we can say कि valency is number of valence electron or 8 minus number of valence electron. Now what is the logic behind it? See, valency is a very old thing. It was mainly based on the fact that I have to complete my octet. I have to complete my octet. Clear? ठीक है ना? Combining capacity means the main logic is that I have to complete my octet. ठीक है ना? So what is happening there? I will write few things first. Like suppose you are having group 1. I am writing here group 1, 2, 13, 14, 15, 16, 17, 18. Okay, and then we will write here valency. Now you know कि group 1, how many valence electrons are there? Acha, we know this trick also na कि group 1 is there, 1 valence electron. Group 2 is there, 2 valence electron. Group 13 is there, 3 valence electron. 4, 5, 6, 7, 8. So the target is to complete octet. Either you gain or you lose. Okay, either you gain or you lose. Like suppose you are having 1 electron, it is easier to lose electron. So the valency given here is 1. In group 2, we are having 2 valence electron. It is easier to lose electron 2. So the valency is 2. In 13, it is easier to lose 3 electron 3. In 14, 4. Like this they have said. Okay? But from 15, what they are saying, listen carefully. This is NCERT thing which is written. And in NCERT, this point is also written. Ki nowadays, we are less concerned with valency. We are more interested in oxidation state. That gives a better idea. So now, how many valence electron in 15? Can you tell? How many valence electron in 15? How many valence electron in 15? 5. So there are two possibilities now. Either I give 5 electrons, that is my I will get a noble gas configuration, or I gain 3 electrons. Or I gain 3 electrons. So they have written 2 things, 3 also and 5 also. Similarly in this, either you gain 2 electrons or you lose 6 electrons. In 17, they are saying either you gain 1 or lose 7 electrons. In 18, octet complete only, so they have written 0 or 8. So we can simple say like this, ki valency, they have written in NCERT like this, ki for representative element, either it is valence electron or they are saying 8 minus valence electron. We will touch all the points. We cannot go in detail in everything now because in detail you will study in blocks, S block, P block, all these things. Okay? Is it clear, Bharat, Manish? Let's see. Okay. So this point they have written. Then they are saying the oxidation state is there. And you know something about oxidation state, ki fluorine, it will have only -1 in combined form. So they have given the definition of oxidation state. They have given the definition. Purely we are going through NCERT. We will not go in detail of all these topics because detailed part will come in later chapters. Blocks deleted from CBSE, na? But from NTA point of view, NEET point of view, nothing is clear, Akash. Clear? So oxidation state. What we say oxidation state? We simply say like this, ki it is the imaginary charge. We say like this, ki it is the imaginary charge. Imaginary charge which appears on an atom. Which appears on an atom when all its bonds are broken. When all its bonds are broken. So now 2 examples they have given in NCERT. We will not go, we can write many more. Like you can also tell few things. Like suppose if I are having Na2O. Can you tell me what is the oxidation state of Na? We say +1, losing electron. What is the oxidation state of oxygen? -2. But if you combine suppose oxygen with fluorine, like suppose you are having O2F2, we know that fluorine can have only -1 oxidation state. So what will happen? Oxygen will have +1. Oxygen will have to give +1 like this. Suppose you are having OF2, so fluorine is -1, oxygen will have to get +2. Like these things. So if you know, all of you are long-term people only, so we expect ki a bit of oxidation state you already know. ठीक है ना. So we are just touching the topic and we are writing the oxidation states which is already known. Okay, from this example it is clear कि oxidation state is a variable term. Oxidation state is a variable term. Is it clear to everyone? देखो, so in combined state, to whom you are combining, that will decide the oxidation state. So all these things are basic only. All of you were knowing this point. How many of you were knowing these things already? Ki sir, these are the points given. Clear? So these are the basic things. More detail we will see later on. Okay, now come directly. We are touching all the points. So the next point you can say ki we can talk about anomalous behavior. What do you know about anomalous behavior? Do you know something about anomalous behavior? बताओ. Anomalous behavior. Anomalous means what? Irregular. Anomalous means what? Irregular, abnormal, means out of the box, man, not matching with anyone. ठीक है ना? So anomalous behavior means something different. So we say like this कि second period element. Who are second period element? Can you tell? Who are second period element? Can you tell me who are second period element? You will say like this, sir, very easy. I will start with lithium. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. ठीक है ना? Like these things we can say. Alkali metal नहीं. We are talking about second period. ठीक ना? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Like this we can talk. So what they are saying ना कि these are different from. This is your second period element. Then there is third period, fourth period, and rest. They are saying कि second period element is different from rest of the elements in their group. Like lithium is different from sodium, potassium, rubidium, cesium. Different. So this one is only known as anomalous behavior. Second period elements have anomalous behavior. Their properties are different from rest of the elements in their group. Is this point clear? ठीक है ना? So what we say like this कि properties of second period element. Properties of second period element is dash from rest of the elements in their group. So what you will say? What we should write in the blank part? What we should write in the blank part? ठीक है ना? So properties of second period element is different from. This is only known as anomalous behavior. Clear? अच्छा, few examples you can take. We will not write many examples, but few examples we understand. One point is very famous. You remember कि except lithium and beryllium, S block compounds are predominantly ionic. Have you heard about this statement? This comes in periodic table 2 times. They are saying that lithium beryllium compounds are having more covalent character. They are having more covalent character. ठीक है? And rest of the S block elements are ionic. ना? We know ना कि S block elements are highly electropositive. They will lose electron. They will become cation. They form ionic compounds. But finally, what we say? कि lithium and beryllium compounds are having more covalent character. ठीक है ना? Do you remember this point? How we can explain this? We can explain this on the basis of Fajan's rule. Fajan's rule you study in chemical bonding chapter. So this is one point. Like we can take some examples. We are taking. This is one example. Second example. You remember covalency? Second period element can have can have maximum covalency. Maximum covalency how much? Maximum covalency of 4. Covalency means you can say simple covalent bonds. Covalency means what you understand? बताओ covalency मतलब क्या बोलोगे? What do you will say about covalency? Covalency, electrovalency. So covalency is nothing else but how many covalent bonds you are making. ठीक है ना? So second period elements can form only 4 bonds maximum, because you know in second period we have 2s and we have 2p. 2s means 1 orbital, 2p means 3 orbital. All together they have maximum 4 orbitals. 4 orbitals means how many electrons can be there? Batao. 8 electrons maximum. 8 electrons means how many bonds? 4 bonds. Clear with this point? So they cannot expand their octet. But what you can say? But third period onwards. Example you can take. Example suppose BF4 minus. Boron can form maximum 4 bond. Carbon can form maximum 4 bond. CCl4. They can never form more than 4 bonds. So BF4 minus NH4 plus CCl4 all are having how many bonds? 4 bonds. But third period onwards, they can what? They can what? Batao. They can expand their octet. Expand their octet. They can have 6 bonds. They can have more than 4 bonds. What example they write? AlF6 minus. See, boron having 4 bonds only, but aluminium can form 6 bonds. ठीक है ना? You know SF6. 6 bonds. H2SO4, sulfur is having 6 bonds. So this is the second anomalous property. Is it clear? There is one more anomalous example given. This is first example you can say, second example and third example. All these examples are clearly mentioned in NCERT and these will be taught to you again in respective blocks. Like all these points will come once again. All these points will come once again. So now you have to reply to this question. Why second period elements can have maximum covalency 4? Batao jaldi. Why second period elements can have maximum covalency 4? Why? Because they have only 4 orbitals. There are no d orbitals. Correct? Understood the point? Yes or no? In second period we can have only 2s, 2p. You don't have 2d. Okay? Okay, fine. So I'm writing the third point. One more point is written there. Ki second period elements can easily form, you can say easily form p pi multiple bond, p pi multiple bond. ठीक है ना? But third period onwards, less chances there. Like you will see like this, carbon very happily making 3 bonds, nitrogen very happily making 3 bonds, oxygen N double bond, oh, pi bond is also there. So like this. But as you will move in third period, they prefer generally single bond. So now the question arises ki why there is anomalous behavior. Reason for anomalous behavior. All of you know this point. Tell quickly. Reason for anomalous behavior. Why we have anomalous behavior? Finally, we have seen that there are 3, we can say mainly ki covalency not more than 4, p pi very easy. ठीक है ना? But why? So this is happening because second period elements are small in size. So first point, small size. Second point, we say high polarizing power. Polarizing power. What is polarizing power? We understand this in Fajan's rule. You can also say this in other way. That is your charge to radius ratio. Charge to radius ratio. This is high. Charge to radius ratio is high. Third point, we can say comparatively high electronegativity. And fourth point, finally, which you were saying, ki absence of d orbital. Absence of d orbital. So is this point clear to everyone? Hope you all were knowing all these points already. I told you today class miscellaneous things, small topics which we will study in future in more detail, and most of the things you are already knowing. So can you see we have written everything correct till now? Yes or no? Check it out. Okay? So what is the reason for anomalous behavior? Small size. Lithium, beryllium, boron, carbon, nitrogen, oxygen, they are very small in size. What is the second point? High polarizing power. Although we can explain all these things, you can think like this, ki suppose some cation is there, it will attract the electron of other. It will make him plus minus, that is polarizing. Polar means what? Plus minus. Creating somewhere plus minus is known as polarizing power. That is dependent on charge to radius ratio, which is very large. Polarizing power. Charge to radius ratio. Large charge to radius ratio. You can say like this also. Ki large charge to radius ratio. Clear? Okay. Comparatively high electronegativity. You know electronegativity. Aarti, you are coming in the class for the first time, I think. Before this you attended the lectures. This is the last topic or last class of periodic table. Is it clear? Comparatively high electronegativity. You know down the group, what happens to electronegativity? Down the group, what happens to electronegativity? Batao. Down the group, what happens to electronegativity? Electronegativity decreases. So who is having maximum? Upper one. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, they are having comparatively high electronegativity than this one. Acha, this one is the reason behind what? Maximum covalency. Clear? So those who understood, just give a like quickly. Let's see how many of you are getting it. Okay? So all these points we have already studied. Okay? Somewhere. Clear? Now come to the next thing, that is your diagonal relationship. Acha, now we have seen one thing. Diagonal relationship. What we have seen here, a second period is different. Second period is different. Second period is different. Clear na? Second period is different from rest of the elements in the group. Then who it is similar to? So what they found na, ki like lithium, see here everyone, lithium, beryllium, boron, ठीक है ना, who is after this? Sodium, magnesium, aluminium, boron, carbon, silicon. You said ki sir, properties of lithium and sodium not similar. Properties of beryllium and magnesium a bit different. Properties of boron and aluminium also sir bit different. So what they found, ki they are not resembling to the element in their group. They are resembling to the diagonal elements. Lithium is similar to magnesium. Beryllium is similar to aluminium. Boron is similar to silicon. Although it is not valid everywhere. So in few limited cases you will find. ठीक है ना. So what we are seeing here, कि अरे diagonal it is matching, diagonally it is matching. Now the question arises, why, how this is happening? In a group the properties should be same, in a group properties should be same, but here something different thing happening. Diagonally you are same. This one is only known as diagonal relationship. This is only known as diagonal relationship. ठीक है, clear this point? So can you tell me the reason? What is the reason for diagonal relationship? Reason for diagonal relationship, they say, like in case of lithium and magnesium, they have similar size. So similar size, ठीक है ना. What is the example? Size of lithium and magnesium is almost same. Size of lithium and magnesium is almost same. How we can say? See, we can say like this: when you move in a period, size decreases. When you move down the group, size increases. What will happen if you move diagonally? ठीक है ना. This side you go, decreases. This side you go, increases. Diagonally you can say similar. ठीक है. Then there is one more reason. They are saying if size is not same na, if size is not same, then what? Charge to radius ratio, ionic radius ratio is same. Charge to ionic radius ratio is same, like we see in case of beryllium and aluminium. They say कि size of beryllium and aluminium not exactly similar, but if you take the charge, what is the charge of beryllium? 2 plus. What is the charge of aluminium? 3 plus. And their ionic radius ratio, then this ratio is becoming same. So anything, either this or that. Clear with this point? So properties are similar. Now which properties are similar? So we will see this in future. Like beryllium one, I can tell you at least कि beryllium oxide and aluminium oxide both are amphoteric. Beryllium oxide and aluminium oxide both are amphoteric. Do you remember any other diagonal relationship? Do you remember any other similar property between beryllium and aluminium? One thing I told, amphoteric oxides. Do you remember something? Clear? So this is the point. Done. Now we are moving to the final topic. So we are having half an hour almost, and this topic will continue for next half an hour. What is that topic? That topic is oxides. Nature of oxides. So we have divided the oxides into 4 parts mainly: acidic, basic, amphoteric, and what you can say, neutral. We have divided this into 4 parts. Oxides, we have divided this into 4 parts. ठीक है ना? Okay. So you are saying कि reactivity with air and oxygen is less. ठीक है. So now let's talk about acidic oxide. You know this point कि metal oxides are, do you know something like this कि metal oxides are generally, fill in the blanks. Metal oxides are generally what? Metal oxides are generally, bolo, non-metal oxides are generally. So the first part is your basic, second part is your acidic. So metal oxides are generally basic, non-metal oxides are generally acidic. We know this and we are writing the point generally. ठीक है ना? And you can say metalloids. or near to that are generally amphoteric. ठीक है ना? Now the question is, what is this basic oxide, acidic oxide and all? So you can say like this point also, this is true, कि basic oxides react with, if you are base, you will react with acidic oxide. If you are acidic, you will react with basic oxide. If you are amphoteric, then what will happen? Acid will react with base, base will react with acid. Simple logic. ठीक है ना? North pole will attract south pole, plus charge will attract negative charge. ठीक है? Amphoteric oxides react with both what? Both acidic as well as basic. ठीक है? Or you can say like this also in one way. Now this will help you, means acidic oxide, basic oxide reacts with acidic oxides, or you can say acids. Acidic oxide reacts with basic oxides, and you can say also base. They can react with acid as well as base. Neutral oxide, what you will say? Neutral oxide. What you will say? Does not react with both. Does not react with both. So do you understand the difference between amphoteric and neutral? Amphoteric means it will react with acid also, it will react with base also. It will react with acid also, it will react with base also. ठीक है ना? But what is happening? Neutral oxide, neither acid nor base. Correct, Durga. So basic point is clear. कि there can be acidic oxide, there can be basic oxide, there can be neutral oxide, there can be amphoteric. Acid will react with base, base will react with acid, amphoteric will react with both, neutral will not react with anyone. Clear? Now let's take some examples. Acha, one more point is there. How you will come to know? How you will come to know that this is an acidic oxide, this is a basic oxide? One is this reaction. Other point is also there. If you put any oxide in water, you tell me this is an acidic oxide or basic oxide? Sodium oxide, acidic or basic? Everyone tell quickly. Na2O is acidic or basic? It is a basic oxide. So when you will put in water, you will get base. You will get what? Base. Suppose you take, like I am having a chlorine oxide. Now these both are in NCERT. That's why I am taking this example. Okay? Suppose I am taking Cl2O7. Cl2O7. This is chlorine, non-metal. So this is highly acidic. You put in water. What you are getting? HClO4. You will get 2 molecules of HClO4, which is an acid. So this is also one thing. If you are having acidic oxide, put in water, you will get acid. You are having basic oxide, put in water, you will get base. Clear? Ab batao, can you tell about SO3? SO3 is acidic or basic? SO3 is acidic or basic? Jaldi bolo, tell quickly. SO3 is acidic or basic? Acidic. SO3 is acidic. Now you put in water. Simple, add everything. What is the product we are going to get? H2SO4, which is an acid. So simple way. Put basic oxide in water, base. Acidic oxide in water, acid. Clear with this point? Acha, let's talk about amphoteric oxides. Amphoteric we will talk especially. Acha, amphoteric, many examples you will get. I am writing few examples, like a few famous one I am writing, like BeO, SNO, SNO2, Al2O3, ZNO. These things we know. At least these things we know. There are many more. There are many more. Clear with this point? Acha, whatever we are saying for oxide, na, we can also say the same for hydroxide. We can also say the same for hydroxides also. So you keep this in mind. Acha, I have written only 4 or 5 examples, famous ones. Rest examples are there which you will study in P block. When you will study group wise, na, boron family, carbon family, like that, so then you will study. Okay. Now what you have said about amphoteric oxide, with whom they will react? Batao. They will react with, amphoteric oxide will react with, jaldi batao, with whom? Amphoteric oxide will react with, quickly, amphoteric oxide will react with both. So let's see some examples. Examples are very important. Like suppose I am having ZNO. Suppose I am having ZNO. I will take HCl. I will get ZnCl2. So it is reacting with acid. Acha, sometimes they also ask you question. What question they will ask you? I will tell you. Wait. I can react this one with alkali also, base also, and I get a formula Na2ZnO2. This is your sodium zincate. Similarly, you can do similar reaction with aluminium, Al2O3 plus HCl. What you can get? AlCl3. And if you are taking Al2O3 plus NaOH, then you can get NaAlO2, sodium aluminate. Sodium aluminate. Okay. Now see, I will tell you two things here. One point where many people are having problem. Okay. And second point, one question I have to discuss. See, this is a question of previous year. They gave two reactions and they asked. What they asked, you know? Everyone knows. ZNO, sir, amphoteric. I also know. Zinc hydroxide, you can say amphoteric a bit. So ZNO is amphoteric. Fine. What they asked this. In the first reaction, zinc is acting as what? This ZNO is acting as an acid or it is acting as a base? They asked this. In the first reaction, ZNO is acting as an acid or a base? Tell. In the first reaction, we know it can act as both. It can act as both. But they are asking in first reaction what it is acting as. So you have to see like this. See, you are reacting with an acid. We know HCl is an acid. So if this is an acid, this should be base. If this is a base, then this should be acid. Clear? So they have asked this in previous year. In the given two reactions, ZNO is acting as. And the options were acid, base, base, acid, 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 base, base. Is it clear? Are you getting the point? So these reactions you will have to remember. Now I am going to write examples of neutral oxide. Very important. Keep this in mind. We are having 3 examples of neutral oxide according to NCERT. What are the examples are there? And they will also ask you same example. NO, N2O and CO. Keep this in mind. They will ask you neutral oxides. 3 are given in NCERT, 3 are in our syllabus. You have to remember 3. They will ask you also from this only. So is it clear? Pani also you can say, no problem. Pani also, pani, correct. So pani to everyone knows, na? Pani to everyone knows. So we are seeing these things. So is it clear to everyone? So you got amphoteric concept, you got neutral oxide concept. Clear? Now let's compare. Now let's compare few things. What few things we have to compare, you know? Okay. Okay. What few things we have to compare? We have to do like this. They will ask you now trend. They will ask you the trend. If you are going in a period, what is happening? If you are going in a group, what is happening? Now we know few things. As metallic character increases, what you will say? Batao. Trend. Trend I am talking about. You say कि as metallic character increases, as metallic character increases down the group. So what will increase? Can you tell? Dash increases. If I write like this, then what is dash? As metallic character increases down the group, dash increases. What will increase? Basic nature. Like suppose I am talking about Li2O, Na2O, K2O, CSO2O, Rb2O. Then what you will say? Who is more basic? Although it is not compulsory everything is formed, because in S block you will study lithium forms oxide like this, all these things will be there. Okay, sodium forms peroxide, rest forms superoxide, all these things. Okay, na? So we are talking about basic nature. So I am putting the arrows in increasing order. Basic increases. Same thing is valid for hydroxide also. If they will say LiOH, they will say NaOH, they will say KOH, they will say CSOH, they will say RbOH. You have to follow the same thing. So top to bottom, basic strength increases. Is this point clear? Let's talk now in a period. Okay, na? In a period, left to right. We are talking about left to right. So in a period, as non-metallic character increases, what you will say? As non-metallic character dash, that implies dash increases. Fill in the both dash. In a period, as non-metallic character increases from left to right, acidic nature increases. Can you see this point? Acidic nature increases. Okay? So now let's take some example then. Now let's take some example. What you can take? Batao. Suppose I am doing like this. This is Na2O. This is MgO, Al2O3, aluminium के बाद who is there? Silicon, SiO2, phosphorus, P2O5, after phosphorus, SO3, after sulfur, chlorine. So they will say कि this one is basic, this one is amphoteric. They will say here weakly acidic. They will say here acidic. They will say here strongly acidic. Are you getting the point? As we move in a period, acidic nature is increasing. Is it clear? Very easy thing, very easy things we are studying today. Left to right in a period. What you are seeing here, everywhere the central atom is changing. Everywhere the central atom is changing. Done. Now the question arises, if, see this point, very important, if central atom is same, then what you will do? If central atom is same, all are same element oxides. Like I will give you example, MnO, Mn2O3, MnO2, MnO3, Mn2O7, all are manganese. Now how you will tell? All are manganese. Now how you will tell about the acidic strength? Now how will you tell about acidic strength? Jaldi bolo. So we say like this, if the element is same, apply this concept only when element is same. If central atom is same, then as oxidation state increases, that implies acidic nature, bolo, acidic nature increases. This we have to only apply when what? When element is same. So here we are having +2, +3, +4, +6, +7. Acha, can you see that point? I was writing na ki metal oxides are generally basic. Now you see here manganese is a metal, but this one is acidic. This one is basic. So that's why we use the word generally. Is this clear? Now many people start applying this concept anywhere. I am again reminding you, reminder. Again I am reminding you what? Apply this when the central atom is same. Is this clear to everyone? When central atom is same. All of you got this point? Yes or no? All of you understood all the points till now? We have studied mainly 3-4 topics like valency and bit of oxidation state, anomalous behavior, diagonal relationship, and then we move to oxides. In oxides, we have studied acidic, basic, neutral, amphoteric. Neutral examples you have to remember. Amphoteric, we have written few famous examples. Acidic oxide, put in water, you will get acid. Basic oxides, put in water, you will get base. Acidic can react with base, base can react with acid, amphoteric can react with both. Is it clear? In a period, acidic strength increases, down the group, basic strength increases. If element is same, check the oxidation state, done. Now come to the new points, few new points we will see. Okay, come to this. So we are talking about oxy acids. Oxy acids they say, or they say oxo acids. What are oxo acids? They will say that there should be double bond O. What are oxo acids? They are saying that there should be double bond O. So nothing different is there. Concept is still same. So let's check this one. Can you tell me what is this order about? You are moving in a period. See, boron, carbon, nitrogen. So can you tell the order? Can you tell the order quickly? So this is the order of acidic strength. Correct. Clear? Now again same example. Come in the third period. Silicon, phosphorus, sulfur, chlorine. In a period left to right, acidic strength increases. So who is a stronger acid? HClO4 or H2SO4? So everywhere we are having same example ki in a period acidic strength will increase. Now let's talk about top to bottom. Top to bottom in a group. What do you know? Ki acidic strength decreases. Top to bottom what happens? Batao, acidic strength decreases. So this side acidic decreasing. Why acidic strength is decreasing? Because metallic character is increasing. Down the group metallic character increases. So can you say who is a stronger acid here? HNO3 or S3PO4? HNO3 or S3PO4? Which is stronger? Same thing you can apply in case of HClO4, HBrO4, HiO4, like this. Is it clear? Very good. So in a period, down the group, we have written many examples. Come to this. What is the concept of this? This is your nitrous acid and this is your hyponitrous acid. So which concept you will apply here? Batao jaldi. Which concept you will apply here? Yes, you will say, sir, elements are same. See here, elements are same. Then you find the oxidation state. What is the oxidation state here? +5. What is here? +3. What is here? +1. So I think you are getting here +1. Okay? Similarly, same thing. Here you will get +7. Here you will get +5. Here you are getting +3. Here you are getting +1. So if element is same, check the oxidation state. If you are knowing how to find oxidation state, very good. If you don't know how to find oxidation state, then wait for the chapter redox. Although we are talking about repeaters long term, you should know these basic things. Clear? Acha, one thing I was telling you before in this, what I was telling, wait, kahan gaya? So we were talking in this part generally people have a problem in writing the formula. In writing the formula, many people I have seen problem. Okay, sodium jincate, sir, how to write the formula? NaZnO2 or Na2ZnO2. Sir, sodium aluminate formula, I don't know. Arey, no problem. What you have to do? You know na oxidation state. Zinc is in which oxidation state? +2. Always. So what? If anyone will write the formula NaZnO2, then this is wrong. Why? In this case, you try to find the oxidation state of zinc, you will get it +3, which is wrong. Got the point? So we can verify the formula from oxidation state. Is it clear? So this was one of the point which I wanted to tell you. Clear? Okay. Now last thing is there. This is totally your choice. If you want to study this one. Otherwise you can skip. This is about anhydride. You know what is anhydride? What is anhydride? Anhydride is the compound which you get after removal of water. Remove water from acid. If you remove water from acid, you will get anhydride. Like see, H2CO3 is an acid. What is its anhydride? Can you tell? H2CO3 is an acid. What is its anhydride? So this is just reverse whatever we have studied in the beginning. I told you na, take oxide, put in water, you get acid, acidic oxide. Put in water, you get base, basic oxide. Okay, na? Now you have to do reverse. You are having acid, remove water, H2O. So what is left? CO2. So CO2 is anhydride of H2CO3. H2O you have to remove. Gaming, Kavita, Joshna. H2O you have to remove, not only H2. H2O. Clear? Remove H2O from this. एक बार देखो इधर. Remove H2O. What you are getting? Remove H2O. Okay, clear with this point? So when you remove water from acid, you get anhydride. So CO2 is anhydride of H2CO3, you can say. SO2 you will get. SO2 is anhydride of H2SO3. Achha, how to tell this? So in few cases, na, like these cases, all these cases, what you have to do, take two molecules. This we will not say. See, I am telling you the method how to tell. Take two molecules. When you will take two molecules, what is the formula? Can you tell? What is the formula? H6P2O8. Are you getting this? Remove all water molecule. Remove all water molecule. How many water molecules I can remove? Jaldi batao. How many water molecules I can remove? Can I remove 3 water molecules? Bolo yes or no? Yes. After removing 3 means 6 hydrogen and 3 oxygen, what is left? P2O5. So P2O5 is your anhydride of H3PO4. Is it clear? So we are almost ending the lecture now. Do you remember which oxide we added in water and you got HClO4 in the beginning? NCERT question also. Do you remember which oxide we added in water? We got HClO4. NCERT solved example. Cl2O7. How to get Cl2O7? Take two molecules again. HClO4. HClO4. What is the total formula? H2Cl2O8. Remove water. Remove water. How many water I can remove? Only one. See here, I can remove only one water. So what I am getting? Cl2O7. So you remove one water molecule, you will get Cl2O7. Is this clear? So that's it for today. So hope you understood everything, basic points we were seeing. ठीक है ना? Now you go and watch this video again in some slow mode also. So you will find that most of the things you will understand because we are studying easy things only. This is the QR code. Is it clear? So what we have done today, we have mainly talked about oxides. We know anhydride also. One just remind me, what do you mean by anhydride? Jaldi se bata do, what do you mean by anhydride? What is anhydride? How you get anhydride? Remove water from acid. Remove water from acid. Take care of Cl2O7, that is in NCERT. P2O5. P2O5 can be also written as P4O10. Clear? Neutral oxides example we should know. What are amphoteric oxides which can react with acid as well as base? Few famous examples we have written. Rest we will see in the block. Diagonal relationship due to similarity in size or charge to radius ratio. Anomalous behavior due to small size, absence of d orbital, high electronegativity. All these points are there. So done. That's it for today. So your syllabus will be till this point only. Electronegativity, go through NCERT once, read it, what is given, and these things. So hope you learned something new. Okay? So just go through the video once again and go through the notes also, whatever we have studied. Okay? Chalo. Any problem? No problem. Bharat, Bleshi, Durga Prasad, Jameer, Kavitha. 2 Kavitha are there. Okay. Next, which chapter we will see once? But I think learning based will be only there. Sajid, Naved. Chalo, ठीक है. So study nicely. Be happy. ठीक है. चलो ठीक है. Thanks everyone. Bye bye.